Cool. Okay. Um, Last week we talked about Docker and just getting our Docker containers up and running. So we're able to have our machine learning in one and our React app in another. Um, this week we're just looking at like machine learning and just the back end in a sense. So because of that, uh, we'll be using a couple commands that you might want to type out. I can also copy this as well. So you'll want a command sort of like this to build your just the back end. And then we also need one for running, which is a command like this as well. So just keep that because we'll go back to it a bunch of times throughout this as we're running. And we're just going to be running our backend Docker, not both the React and the backend or the machine learning sort of thing. And that's just because it takes too much time to do two containers. Let's just do one. Alternatively, you could probably get away with just running it on your regular hardware, like on your host system. But yeah, that's really up to you. Yeah, awesome. Yeah, so this week we're doing machine learning and we're just talking about like getting the data, cleaning it, um, how the like manipulation is done, or how we're going to be. I don't know what the word would be, but like to get it ready for our actual machine learning stuff. And then our machine learning stuff is really just like finding things and pulling it out. So if you're not familiar to the difference between like AI, because that's kind of a buzzword, and machine learning, is I think AI is a subset of machine learning. I think it could be the other way around, but one is a subset of another. Um, Whereas AI is actually like more like learning. Or able to like alter itself in order to get better results. What we're doing is more like statistics and a little bit of analysis of a certain data set, and then I don't want to say learning, but like asserting something onto that. Um, just from a high level view of what the machine learning sort of looks like, where we have the data and it's a big data set of different movies with titles and genres and all this other stuff, descriptions. Um, we're taking that, we're going to clean the data. We're going to use this uh, natural language toolkit, I think it's called, in Python, to stem. I think that's the word for it. Stem the words in the titles and in the descriptions. Um, and what stemming is it takes words like running and walking and flying, and it just brings it down to its base form. So fly, run, that sort of thing. Walk, right? Code, not coding. Takes words like that down to its base form, and then we're going to be basically finding movies that also match like same genres and um, genres. Maybe a couple other things. I'm not too sure off the top of my head. Keywords, credits, that sort of thing. Along with that, they don't call it description; they call it overview. Um, Overview, and basically tokenizing a lot of that stuff, and then whatever has the most similarity is what we're going to be pulling. If that makes sense. Hopefully, it does. Um, yeah. So with that, our first step is to get the data set. And so we're going to be using this data set from Kaggle. It's nice and free. You might need to make an account for it. This is called the Movies Daily Update data set. So every day they update with new movies that come out on that day. If there isn't any, I don't think it gets updated, but yeah, the ever expanding list. So if you ever do want to update it, you can just come here and click download again, or make like a Python script or something to pull from this. Yeah. So you can click download and it will download a zip file. Just looking at Kaggle here, something that's pretty cool is they give you a like sneak preview of the data, and so they have the instead of IMDb, they use TMDB, which is the movie database, and it's just a free version of IMDb because with their APIs, you have to like they have more strict, they have stricter rules, and I believe you have to pay, whereas TMDB you don't. Um, and as a heads up, too, we'll be using TMDB later on. Yeah, but we can like look at this is how they do the titles, this is how they do the genres, um, all this good stuff here, popularity, release date, budget, all that stuff. So yeah, that's just a nifty little thing to check out before. They also have some things for code. I've pulled, I think, stuff from this person here to make this machine learning. Um, and we're going to be changing it a little bit. But yeah. Uh, yeah. And I will put this link in the chat. Oh, if it came late, that's okay. We just talked about the last week, talked about the overview. Haven't really done any coding or anything yet. We're just downloading this data set here. Oh, well, give you the wrong link. You might have to click back. I'll share this one. So just the code. This. Awesome. Cool. With that, we can go ahead and unzip it here. Not what I want. Okay. When you unzip it, you should get this like movies.csv folder or file. Um, in our movie recommendation in the back end, we're going to make a new folder and just call that data. And then we can go ahead and just plop that guy right in here. I'm going to ignore this for now. So you can get some extensions that read CSVs. Because this one is huge, I suggest not opening it up, especially in VS Code. Maybe something like Excel, but yeah. Awesome. And another thing too is, I think last time we had this Python as Python 3.9 Slim Buster. It should actually be 3.7. Yeah, in the Docker file. So make sure that gets changed as well. Let me just check this out. 3.7. Yes. Awesome. Are we doing okay? Someone just give me a thumbs up or yes, all good. Yep. Awesome. Cool. Okay. So first things first, we need some files here. So I'm going to get rid of this app.py, or we can just rename it. That works too. We'll rename this one to ML Builder, or whatever you want. So the machine learning builder, or ML Builder.py, will clean the data, import the libraries, just like get everything set up to then be ready to be like asserted on, I guess. and it'll also save some uh, binary files as well, which will make it easier for um, if your thing goes down, you can just rerun it. It's just basically saving all your data from when you cleaned it. And then we'll have another file here, and that one will be called engine.py. And the engine will be a function where we'll pass in a title, and then it will do its thing with actual like asserting something on it. And there'll be more to this as well later on. We'll add some the movie database sort of API stuff to call and get a little bit more information about the movie, as well as like the poster and all this other stuff. Yeah, cool. Okay, now bear with me just a little bit because I am absolutely no expert here. So, so uh, there might be a few stop and go sort of things that happen. We're first going to change the Docker file because we no longer have this app.py. We have this engine and ML builder. We just need to change a few things in here. We are going to say run Python 3. And what are we going to run? ML builder, right? We want to clean it and everything first. And then we want to run the engine.py. Yeah, awesome. Give this a quick save. And then in our requirements.txt, there'll be a couple of things. And I'm also getting prepared for later on as well. So there'll be things that we don't use yet. Uh, so we have Flask and Flask RESTful. Uh, Unicorn. Unicorn Flask cores. The big one, which is pandas and scikit learn, which we will be using that stuff today, as well as matplotlib, image, and TK, which is natural language toolkit, Seaborn, Streamlit, NumPy, and Pickle 5. And just in case, I'll throw this in the chat as well. Just in case, because it's kind of just a list of things. So awesome. Cool. Okay, so in Python, if you specify your requirements.txt, when you first like run something, you can specify like, oh, like download all these packages from the requirements.txt. It's just sort of splitting up your libraries from your actual code. Yeah, that's all that this is doing. And we can check in here, we copy it, and then we say, okay, pip, so like Python, install all the requirements here. Cool. All right. One major last thing is we don't want to commit that movies.csv or like any of the pickle files as well, because those will be big and Git doesn't like big files. You could get away with using something called LFS, I think is what Git calls it, large file system, or storage. And it does this weird thing where like omits big files and just uses like pointers to them so you don't get errors. It's a little bit confusing and kind of advanced. I tried it a couple times, it didn't really work out. Um, it's best just to omit, omit it uh, and download it when we push it up to somewhere. So to do that, we can just say like uh, data movies.csv. Or another thing we could do is just data slash all. So that should omit that stuff. It is not. There we go. Backend slash data slash star for all. Cool. Okay. Now we can get onto the machine learning stuff here. How are we doing? Everybody still able to follow along? Yep. Awesome. Okay. So first sort of goal is to get our CSV in Python, and we will start cleaning it. So first things first, we got to import the libraries. So first we're going to import pandas as PD and import numpy as NP. Then we're going to say panda set option max calls display.max columns is none. And this will make sure that we're going to be showing all the columns in that CSV. There's also a couple more imports here. So matplot.lib dot pyplot as plt. Hoping everybody can see. And import Seaborn as SMS. And our last one, not our last one. Seaborn, oh wait, we already did this. Import NLTK. Now from the natural language toolkit, NLTK, because it's rather a big package, we can just select the individual things that we want. So we want the stem, snowball as snowball stemmer. So this is that ability to take the words with added things in it, like running and walking, or like walks, or flies, and trim off the excess there just to get to the base form. That's what the stem, and it's not steam, it's stem. From scikit-learn, we also need to get our feature extraction. And so feature extraction is kind of like what columns you're going to be using. We're going to be taking like text, TF-ID vectorizer. I think TF stands for TensorFlow. I think. I could be just making that up. But and then more scikit-learn metrics. We're going to be taking the scikit-learn.metrics.pairwise and grabbing the cosine similarity. Okay. Lastly, you need to import pickle. Okay. Hopefully we're good now. So our first step is to get that data inside. And we do this using pandas. We can say read CSV. We don't want data. We want slash dot slash data slash movies.csv. And DF is going to stand for data frame. So there's quite a bit of, there's like data frames and data sets that sort of happen as we code along. Yeah. So with that data frame, we want to drop any duplicates. And we want to have the title if there's duplicates in the title, but we also want to match to see if there are duplicates on release date. Right? Because you could have like two Spider-Man movies, right? Both called Spider-Man, but most likely they're not going to be on the same date of release. So this is just a way for us to clean it up and get rid of any excess movies that are the same, just on different dates. Or if it's like Spider-Man in Canada versus Spider-Man in the US, might have different dates of release, or like somewhere in the UK and over here in North America, right? There might be different release dates. So yeah, this is just a way to say, okay, these two movies that are the same, um, you know, uh, they're not, um, and we can remove them. Okay. Now we're going to specify a new data frame from the old data frame. And we want anything that has a greater vote count of 20. And that's, again, just to shrink down the amount of movies that we are looking at. You could omit this. You could change it from 20 down to like 10 or 5 or something. Um, Again, it's just a way to ease the load on our system and resources, because we want to go through the whole list, right? It's just looking at um, anything above the certain spec. So there is a vote count column. It is not going to be that. It is going to be 20. Reset index. Awesome. Cool. With that data frame, again, we are going to start cleaning the specific columns here. So there's the genres column, df1. We want to take that genres column, genres, and apply. If you don't know Python that well, lambda is an expression for like building a function inside of a function, or like a mini function basically. And so it's going to iterate through and find anything with a, not with a space. It's going to remove the hyphens in it, because the hyphens could put some added implication on our like stemming further down the line. So just split it and we'll just let the natural language toolkit do its thing. We have to do something similar to keywords. So df1 keywords is equal to df1 again. Keywords, and that looks good to me. You could probably copy the last line and just change genres to keywords. And then in df1, in the credits, this one is going to be a little bit more funky. I'm going to do kind of the same thing, but our lambda is going to have, instead of this split here, replace okay. Okay, sorry, I did not explain that one very well. So we're going to be looking at the credits column. Anything with a space, we're going to remove the space. And same thing with the hyphens here. We're going to be doing the same thing. And then we're only going to select the first 5 words, because I believe, let's go back to this guy. Look at credits. Oh, we can't look at credits. 20 columns. Okay, let's open this up. I want to see what credits are. If credits are either people or if they are what? I think they're people. I'm going to say that they're probably people. So we want like the first 5 actors, I guess, or people that have been directors, key people of the film. So we can use that to say, oh, if you like this Wes Anderson film, you might like this one. That sort of thing. Cool. Still with me? I certainly hope so. Okay. So now we're going to combine all of the columns that we want, which is genres, keywords, credits. There's also a few other things like overview. Overview. Overview and df1. Make this original language. Okay. Cool. Okay. Now for the actual sort of machine learning part, using the natural language with Python and NTLK, it is very, very easy to do, which makes our lives much easier. So we're going to start by defining this function called stem. And then in stem, we'll have a array. In this case, I'm calling it y. So for every word in the text, we are going to say make this new array um, with we're going to take all the words, right? Iterate through the words, stem every single word, and with that new word, we're going to attach that to the Y array, um, and then return all of that. This line right here will initialize the stemmer for what English we're looking at, or what English, oh my gosh, what language we're looking at, which is English. Um, and then, yeah, that's basically it. Uh, there's obviously still a few more things we have to do, but let me just double check here. Mhm. Cool. Yeah. Okay. Now with df1, tags of df1, we need to apply that stem. So we're going to be calling this function here with each of the overview, genre, keywords, credits, I think it's original language. df1 again. Then we're going to take the tags, df1, tags. Another thing we need to do is we want to replace the exclamation marks. It does seem odd that I'm doing it afterwards. This is just the tutorials, and when I was playing around with this on I think Tuesday or Monday, um, switching any of this up gave a lot different results. So feel free to like play around with this after. This is just sort of what worked for me. So we're using regex. So this is just taking out all the punctuation marks from the tags. Cool. And then TF-IDF. This one initializes the TF-ID vectorizer with English words, and then we want to apply that. And so this will end up making a matrix of the results from like tokenizing and that sort of thing. Cool. Now, lastly, here we're going to dump our stuff, and we're going to use pickle for that. We want to dump this, and we want df1, and we're going to call this movie list. Awesome, and then print. Cool. Okay. Any questions that I may or may not be able to answer here? This is all of the cleaning and getting machine learning like ready. We have one more thing that we have to go through, and it's small. Maybe it's small, maybe 30 lines or so, to actually run the stuff. Any questions though before we keep going? If you didn't catch all this, it will be pushed into our Git as well, so you can always just pull from that or check it out later as well. If I don't hear anything, I'm just going to keep going. Okay, why don't we test to make sure all of this works? So with that command that I sent before, we can build our back end. Yeah, yeah, that's okay. I know following code along is sometimes tricky, um, especially something like this, where you can't like test things out yourself, um, in a sense, or like with like styling stuff, you could go ahead and you know figure it out yourself or change the colors or something that you like. Whereas this, it's more, it has to be this way. There could be other ways. I don't know how. So, no such file in directory. Oh, I think because because of this. Yeah, it might take a bit to build here. Because it has to go through the big list of things. Um, and this stuff is from me when I was testing it. I just realized that now. Pip install requirements. Ew. So if that happens, and it's no biggie, what we could do, this is the wrong Docker file. What we want to do is install pip before we install the requirements. So yeah, we can just say another run again. Let's try that again. Hopefully that works. What it is not like in this. Hmm. This should be the same here. Okay. Yeah. My bad. I don't know. I think the order might matter, I guess. So, okay, that's a different error. So for your requirements, if you are following along here, it should be there, that order there. But let's see here. Vote count. I'm going to say, it's going to say, It's this guy here that it doesn't like. Hmm. Very interesting. Okay. Not too sure on what the error is because it doesn't necessarily tell me. Oh, I think it's just double square brackets. Okay. Line 18. Line 18 is saying float object has no attributes split. Hmm. Float line 18. Looks exactly the same to me. But I'm thinking I missed a few things here. So my apologies to go back. Um, there's a couple other things. So we should be df1 fill and a. So if there's anything with like missing values, um, we'll fill it with empty strings because I'm thinking maybe for some reason it's finding nothing and then trying to split it. Um, and then we're going to remove rows that don't have an overview and don't have genres as well. Okay, let's try that. No errors yet, so that we might be good, hopefully. Nice. Cool. Now, let's just run this. Yeah, okay, good. So we didn't get any errors. Also getting someone saying scroll up, which is all good. These are the lines that I just added. Okay, I'm gonna move on just because we only really have like 10-ish minutes left. Um, hopefully you're good. But if not, again, I will throw the link to the GitHub in the chat. Paste the lines. Yeah, I think I can do that. You want all the lines? Just the three? Okay, good. There's a max character limit. There you go. Yeah, and that goes in between the vote count and the genres stuff. Awesome. With the engine, I am just going to sort of blow through this a little bit uh, more quickly. But first, we're going to import pickle, and also from scilern.metrics.pairwise cosine similarity. df1 is equal to pickle load. Yep. There, movie list, and tf. Yeah. Awesome. So importing, grabbing the data, and we're going to specify a function and call this get recommendation. We're gonna throw in a title. Cool. So in here, we'll have this value called ndx, and we're going to try and find the title that matches, and we're going to pull the index of it. We're going to find the similarity score, which is going to be a lot here. Using this cosine similarity, which I think is not a pattern, but I'm not too sure. I don't want to say anything that I don't know. But my notes say compute the pairwise cosine similarity scores between movie at the index and all the other movies in the matrix here. Do that with this line here. So sim score. So this one sorts the movies based on similarity scores in descending order, right? Because we want the most similar at the top, I assume, and the least at the bottom. And then with that, we can get score. We're just going to grab the first 8. So this line basically asserts that tokenizing mechanism. Okay, here we have this movie that has like running 3 times. Are there other movies here that also have running 3 times? And determine a score of how similar those are based on the overview, the genre, the cast, or the credits, I should say. And we're going to put all that stuff in a list. So asserting the whole thing on just the title that we are looking for recommendations on. Then we're going to sort it in descending order to get the things that are most similar. And then we're only going to grab from 1 to 9, or the most similar movie is going to be itself. That's what 0 is. So we're going to select 1, which is the second result, to 9. You could make this like 1 to 20 if you wanted. Now we're going to get the movie indices from that sim score list. We're going to get the results. So this will go through and pull out all the movies with this index, which are the ones that are recommended to us. Okay, and let me just check this one out here. Okay, good. Cool. Almost there. We'll have this recommendation array, and not this in range. So for every movie in range of results, we are going to do some stuff here. We are going to basically build a JSON array. Yeah, just like this. So the title, we want the title, maybe we want the release date, popularity, vote count, not average votes, count, vote count, oh, okay, and the vote average. With that, we're going to return the recommendation, and lastly, print get recommendation. And for us, I'm going to use The Dark Knight. As long as this movie title right for now is a movie that's actually in the list, right? Because if you do like Garfield, but Garfield spelled wrong, it won't find anything and it'll probably throw an error. It just make sure that like when you're doing Harry Potter, make sure you're doing Harry Potter and like the first movie, whatever the first full legit title. And you could find that on IMDb just to double check. We're just omitting error checking for right now. Yeah, I do see that there is an error. I believe it's just one of these. Awesome. Okay. Now we're going to build it again. It's going to do all the running. And then hopefully with this right now, it should just print out that list of title, release date, popularity, vote count, and vote average uh, of all the movies that are recommended from The Dark Knight. Okay, and let us run this. Nice. So we can see here The Dark Knight Rises, which makes complete sense, right? It's the next movie in the Dark Knight series. Um, Batman, which again is pretty obvious. Batman Begins. That one's pretty. Yeah, looks like these are all Batman, which make a lot of sense, right? With the genre, with the overview, with if you think of those keywords that are in it, that are going to be used in the similarity scoring, it's the closest thing to it that is also very popular, and it matches similarly to the movie is going to be the next movie in the series and also other Batman movies. Yeah. that is all the machine learning stuff really for today and for the bulk of this. If you are curious on like maybe playing around to see different things, you could try doing different columns if you're adding like voting average or something like that that you want also in the similarity um, scoring or um, to take in uh, popular movies, right? Um, or maybe you can try and select like five movies that are very popular and five movies that are like mid popular, just to give the user a more diverse set to look at. Yeah, if you want to play around with that, you're more than welcome to. um, yeah, is there any final questions or anything? This one was a lot. This one was a lot. Cool. Well, if there isn't any questions, I'm not sure what I would be pulling, so I'm going to wait on that. Mine is a run. I will copy all of your. Okay, cool. Let me stick around after. Yeah, if you can just hang around for another couple of minutes, I will push this to Git and I will give you the link. That way, there's a character limit, and I don't want to fuss around with it. And you'll also be able to see all that stuff too. So give me one sec. GDSC. Cool. Uh, cool. I have not published this yet. Just give me a few minutes there, and you should be able to pull it from that link. But for everybody else, you're good to go. Thank you for joining. If you do have questions or have any issues or anything, just let me know. This will be posted on YouTube as well today or tomorrow, and you can review it there. Awesome. Okay. Thank you. Thanks for joining. Awesome, Jamie. Okay. I am just worried why I'm pulling. Oh, I know why. Okay, we're good. I thought it was on a different repo, and I was worried I was going to be pulling everything, but it should be good. Cool. Should be good. You should have all that stuff in GitHub here under backend. The only thing you won't have is the data file. But if you need to check out Builder, yeah, and it sucks too because it's like if there's one thing off, right, it's gonna throw